The Juno mission exploring Jupiter is well underway, and it's really cool to learn more about and see new images of the biggest planet in our solar system. Of course, even with these images, it's hard to get a grasp of just how massive Jupiter really is, since it's very difficult to compare it to anything. Fortunately, Yeti Dynamics has a really cool video showing just what it would look like if our moon were replaced by some of the planets, giving you a better idea of the size of some of these objects. It's a really neat video to watch. I have the link down in the description. Now, Jupiter looks so massive in this video, it seems like you could almost reach out and touch it. And that made me very surprised to learn that you could actually fit all of the other 7 planets in our solar system in the space between the Earth and the moon. Now, if that sounds surprising to you too, that's because the moon is actually a lot further away than most people think it is. So to check that out and show just how far away something relatively close really is, I thought it would be fun to scale things down a bit and see for myself. We'll start with the Earth and the moon so I can show you just how far apart they really are. Now, the Earth has a diameter of 12,756 kilometers, and the moon has a diameter of 3,475 according to NASA. So if the Earth was the size of this soccer ball, which has a diameter of 21 centimeters, the moon would be the same as this Super Ball, which has a diameter of 5.72. Now, leaving the Earth here, how far away would you think the moon is? 1 meter? Maybe 2? It's actually all the way over here, 633 centimeters away, with its average orbit being 384,400 kilometers. And at its furthest point in its elliptical orbit, it stretches to 406,696 kilometers, 6.7 meters away from our Earth over there. And if you're curious where the International Space Station is, it's all the way back near Earth, orbiting between 330 and 410 kilometers, just 5.4 to 6.7 millimeters away from our soccer ball Earth. We start with Mercury, the closest planet to the Sun and the smallest in our solar system. Now, Mercury has a diameter of 4,879 kilometers. At this scale, it measures down to 8.05 centimeters, the same as this T-ball. Now, being the closest planet to the Sun, Mercury absorbs the hottest rays, but due to its lack of atmosphere, the temperatures can actually vary from 430 degrees Celsius to negative 170 at night. Then there's Venus, the planet closest in size relative to Earth at 12,104 kilometers across. Scaling down here, it's just a shade under 20 centimeters, the size of this volleyball. Now, Venus has the slowest rotation of any planet, meaning it has the longest day. It takes 116 Earth days and 18 hours to complete one spin. It is also the hottest planet in our solar system thanks to its thick carbon dioxide-rich atmosphere, which leaves it with an average surface temperature of 467 degrees Celsius. Next, we come to Mars, a planet inhabited entirely by robots that we hope will be home to humans soon as well. Now, Mars is a little over half the size of Earth, at 6,792 kilometers in diameter. Scaling down here, that's 11.11 centimeters. Now, while Mars may be the second smallest planet, it is home to some of the biggest things in our solar system. Olympus Mons is the tallest mountain at over 25 kilometers high. Now, with Mount Everest coming in at 8.85, and Mauna Kea, the big island of Hawaii, coming in at a little over 10, our biggest peaks are nothing compared to it. Martian dust storms are also the most furious in the solar system, as they can cover the entire planet and last for months. Next, we come to the gas giants, starting with Jupiter. As I stated before, Jupiter is the big brother of the solar system, coming in at a whopping 142,984 kilometers in diameter, and it is represented here by this 235.77 centimeter board. Now, Jupiter is so massive that while light can travel around the equator of Earth 7.5 times in 1 second, it can only make it about 2/3 of the way around Jupiter in the same amount of time. And that makes it all the more impressive that Jupiter has the shortest day in the solar system, completing a rotation in just 9 hours and 55 minutes. Then there's Saturn, with a diameter of 120,536 kilometers, scaled down here to 198.75 centimeters. Now, of course, that's just the planet. If we took the rings into account, it would be a lot bigger, as the largest of which, the nearly invisible E-ring, which stretches between 360 and 960,000 kilometers, would be between 5.9 and 15.8 meters at this scale. Next, we come to the ice giants Uranus and Neptune, nearly identical in size and color. Uranus has a diameter of 51,118 kilometers, scaling down to 84.29 centimeters. Now Uranus is one of just two planets, Venus being the other, that spins clockwise on its axis, meaning that the sun rises in the west and sets on the east in these planets. Uranus is also the first planet to be discovered with help from a telescope, first noticed by John Flamsteed in 1690 and confirmed as a planet by the observations of Sir William Herschel in 1781. Neptune is just a bit smaller at 49,528 kilometers across, scaling down to 81.67 centimeters. Neptune is interesting because it was discovered using math, as Urbain Le Verrier of France and John Couch Scott of England both independently predicted its existence due to its gravitational effects on the orbit of Uranus. It was confirmed as a planet on the night of September 23, 1846 at an observatory in Berlin by Johann Gottfried Galle and Heinrich Louis d'Arrest.
You could even fit in the 5 known dwarf planets. There's Pluto, the most famous one, Eris, Haumea, Makemake, and Ceres, the largest object in the asteroid belt that scientists aren't sure whether to classify as a dwarf planet or an asteroid.
So there it is, all of the planets in our solar system easily fitting between the Earth and the Moon. It really is cool to see just how far away everything really is, and that even our closest celestial object, the one we all see every day and look up to every night, is actually really far away.